So I'm continuing with chain rule problems in this video. I believe I'll just go through a bunch of chain rule examples, and we're going to do it faster than the previous video. We'll just see what the different functions are composed of rather than writing everything out explicitly, because that on tests, and eventually it's good to just learn how to do that. So we have f prime of x. They ask us to find the derivative of this function. Okay, let me try that again. F prime of x is equal to 5, right? The 5 comes down. And inside, this is a single, this can be looked at as a function inside another function. So we'll just write this out. Then times the derivative of this, which is going to be 4x to the third plus 6x. Next problem is problem 8. We have, I'm going to write little f, whatever. F of x is equal to 4x minus x squared to the 100th. Oh, wait. Yeah, this should be 4 over here. Okay, so f prime of x is equal to 100 4x minus x squared to the 99th power times the derivative of this thing inside, which is 4 minus 2x. Okay, next problem, problem 9. We have f of x is equal to, and I'm just going to write out what this is, 1 plus 2x plus x to the third to the 4th power. So f prime of x is going to equal 1/4, 1 plus 2x plus x to the third to the 1/4 minus 1 times 2 plus 3x squared, because again we take the derivative of the inside function. That was problem 9. Problem 10 gives us f of x is equal to 1 plus x to the 4th power to the 2 over 3. So we have f prime of x is equal to 2 over 3, 1 plus x to the 4th power, and then we're going to have 2 over 3 minus 1. All this times the derivative of this thing inside here, which is 4 times 3 to the 3rd power. Okay, problem 11, g of t is equal to 1 over t to the 4th power plus 1, all this to the 3rd power. So g prime of t is going to be, so by the quotient rule, let's just write everything out. We're going to have t4 minus plus 1 to the 3rd power times 0, the derivative of 1, minus 1 times the derivative of this, which now we're going to use the chain rule. We're going to get 3 times t to the 4th power plus 1. And then now we're taking the derivative of the function inside, which is times 4t to the 3rd power, and this has a 2 over here, all over t to the 4th power plus 1 to the 6th power, and this we can get rid of. So we're left with negative 3, because that dropped down, t to the 4th power, and then we took the derivative inside. This looks fine. Okay, that was problem 11. Problem 12, we have f of t is equal to 1 plus 10t to the 3rd power, not third, whatever, to the, I don't know. Anyway, so this is going to be 1 over 3 times 1 plus 10t to the 1 over 3 minus 1, and then times the derivative of the thing inside, which is going to give us secant squared t. Because the derivative of 1 plus tangent t is secant squared of t. So problem 13 gives us y is equal to cosine a to the 3rd power, where a is a constant, x to the 3rd power. So we have dy over dx is equal to negative sine, then we just write in the inside function, times the derivative of the inside function, and the derivative of a to the third is just 0, so we get, that's the derivative. That's 13th question. Question 14 gives us y is equal to a to the third power plus cosine 3x. So y prime is going to be, so the a is going to vanish, and we're going to get 3 cosine x squared, because this cosine 3x is just cosine 3 to the third, so the 3 drops down, and then you get a -1 over here, and then times the derivative of the inside function, which is cosine in our case, which gives us negative sine x. So, okay, problem 15, we have y is equal to x. It's really, okay, so let me write what they say, and then, so x secant kx, which I'm saying is equal to x over cosine kx, so dy over dx. So now we're going to use the quotient rule over here. We're going to have cosine kx times the derivative of x, which is 1, minus x times the derivative of cosine kx, which is negative sine kx, right, because the inside function remains the same, times the derivative of kx, which is just k. All this over cosine kx squared. Next problem is problem 16. We have y is equal to 3 cotangent n that. So this is equal to 3 over tangent n times that. So y prime is going to be, so the first derivative is 0, quotient rule, right? The first thing is 0, so the next thing is going to be negative. And then the derivative of tan is secant squared. And then the inside function remains the same, but then we take the derivative of the inside function, so we get an n out here. And then times, oh, and there's a 3 here, tangent n by squared. Problem 17, we have g of x is equal to 1 plus 4x to the 5th power times 3 plus x minus x squared to the 8th power. Probably should actually, product will, okay, let's see. I hope I'll be able to do this on this page. So g prime of x. So first we're just going to leave this the same. We're going to do the product rule. It's this to the 5th power, and then we're going to take the derivative of this, which is 8 to the 3 plus x minus x squared to the 7th power times the derivative of this, which is going to be 1 minus 2x, and then plus, and now we leave this the same, so we get 3 plus x minus x squared to the 8th power times the derivative of this thing, which is 5 times 1 plus 4x to the 4th power, and then times the derivative of the thing inside, which is 4. Okay, next problem is problem 18, which is similar. So we have h of t is equal to t to the 4th power minus 1 to the 3rd power times t to the 3rd power plus 1 to the 4th power. So we have h prime of t is going to be, and I'm going to leave this the same, so I'm going to get t to the 4th power minus 1 to the 3rd power times the derivative of this, which is going to give me 4 times t to the 3rd power plus 1 to the 3rd power, then times the derivative inside, which is 3t squared, plus, and now I'm leaving this the same, so I get t to the 3rd power plus 1 to the 4th power times the derivative of that, so I get 3 times t to the 4th power minus 1 all this squared, and then the derivative of the thing inside, which will give me 4t to the third power. Okay, next problem is problem 10. I have y is equal to 2x minus 5 to the fourth power times 8x squared minus 5 to the negative third power. Can you do this using the quotient rule, but it probably just dropping this down, but it probably would just be easier to use the product rule and the chain rule. So y prime is going to be, so I'm going to keep this the same and take the derivative of this, which becomes 5 times 8x squared minus 5 to the negative fourth power, and then the derivative of the function inside, which is 16x plus, and now I'm keeping this the same, so it's 8x squared minus 5 to the negative third power times the derivative of this, which is 4 times 2x minus 5 to the third power times the derivative of the thing inside, which is 2. That's this solution. So now let's look at problem 20. So we have y is equal to x squared plus 1 times x squared plus 2 to the third power, to the power of 1 over 3. So now again, dy over dx is going to be, so I'm going to leave this the same, x squared plus 1, take the derivative of this, which is going to be a third x squared plus 2 to the third minus 1 times the derivative of the function inside, which is 2x, plus, leaving this the same, x squared plus 2 to the 1 over 3 times the derivative of this, which is just 2x. No chain rule involved over there. Okay, problem 21. We have y is equal, interesting problem, to x squared plus 1 over x squared minus 1 to the third power. So y prime is going to be 3, and then we're going to keep the entire function inside the same to the second power. Now we're going to take the derivative of the function inside and multiply it over here. So it's going to be x squared minus 1 times the derivative of x squared plus 1, which is 2x, minus x squared plus 1 times the derivative of x squared minus 1, which is 2x, all over x squared minus 1 squared by the quotient rule. Next problem, we have problem 22. Y is equal to x sine square root of x. So y prime is going to be x cosine square root of x times 1 over 2 negative a half. Right, so yeah, x remains the same. We take the derivative of this, which is cosine of that, with the chain rule. Then we take the derivative of that, which we get that, plus sine square root of x times the derivative of x remains the same. Next problem, y is equal to sine x cosine x. So y prime is going to equal to cosine x cosine x times the derivative of this, which is going to be x negative sine x, right, that product rule over here, plus cosine x, and that's it, right? So again, we take the derivative of this, leaving this the same, and then take the derivative of this, which involves the product rule because we're taking the derivative of x cosine of x, which is x negative sine of x plus cosine x. That's the derivative. Next problem is problem 24. We're given f of x is equal to x over square root of 7 minus 3x. So f prime of x is equal, so we're going to do the quotient rule. We're going to get 7 minus 3x times 1, the derivative of x, minus x times the derivative of 7 and the square root of 7 minus 3x, which is going to be a half 7 minus 3x to the negative a half, then times the derivative of the function inside, which is negative 3, all this over the bottom part squared, which is just 7 minus 3x. Next problem, f of z is equal to square root of z minus 1 over z plus 1. So f prime of z is going to equal, so this is the function inside, and the function outside is basically that, or square root of z. So we're going to get a half, keeping the function inside, to the negative a half power, and now taking the derivative of the function inside, which by the quotient rule gives us this, z minus z minus 1 times 1 over z plus 1 squared. So again, we took the derivative of the outside part, so we dropped a half here, got a negative over here, kept the inside function instead the same, took the derivative of the inside function with the quotient rule, and that's that. So now, okay, probably need another page for that. So g of y is going to be equal to y minus 1 to the 4th power over y squared plus 2y to the 5th power. So y over here. So g prime of y is going to equal, so we're going to do the quotient rule, we're going to get y squared plus 2y to the 5th power plus the derivative of this, which is 4. It's 4y minus 1. The derivative of the thing inside is just going to give us 1, so we don't have to write that. And then minus, and then we write 4 minus 1 to the 4th power times the derivative of this, which is 5y squared plus 2y to the 4th power times the derivative of the thing inside, which is 2y times plus 2, all over y squared plus 2y to the 10th power. Okay, next problem, we have y is equal to cosine pi x over sine pi x plus cosine pi x. So y prime is going to equal to sine pi x plus cosine pi x times the derivative of cosine pi x, which is negative sine pi x, times the derivative of pi x, which is pi, again, chain rule. Then we're going to have all this minus cosine pi x times the derivative of this, which is going to give us cosine pi x times pi plus, and then minus sine pi x times pi. So that's all of that. Right? Yeah. Looks right. All over sine pi x plus cosine pi x squared. So that was problem 28. So now problem 29. We have y is equal to sine tan 2x. So y prime is going to equal to cosine tan of 2x times the derivative of tan of 2x, which is going to be secant squared 2x. Now times the derivative of 2x, which is 2, right? Because we have three functions, one inside of the other here. 2 is inside tangent, which is inside cosine. So, sorry, this is not the function. 2x is inside tangent, which is inside tan, sine. So we get cosine of the first function, and then we take the derivative of this thing, but the derivative of tan 2x would require the chain rule again. It's secant, and then again we take the derivative of 2x. Okay, so now let's look at problem 30. We have g of y is equal to y squared over y plus 1 to the 5th power. So g prime of y is equal to 5 times y squared over y plus 1 to the 4th power times the derivative of this thing inside, which is y plus 1 times y squared minus y squared times 1 over y plus 1 squared. Next problem is problem 31. We have sine y is equal to sine square root of 1 plus x squared. So y prime is equal to cosine of this square root plus the derivative. So now so there's another function inside here. So now we have this function. So we have to take the derivative of square root of 1 plus x squared. So that's going to give us a half of 1 plus x squared to the negative a half. But now we have to take the derivative of this function. So that's times 2. So this is, again, two chain rules. First chain rule, we get cosine and the thing inside, and then we're trying to find the times the derivative of the thing inside. So the square root drops down, we get a negative a half over here, we keep the thing inside the square root, then we take the derivative of it, and we get that. Okay, so now we have y is equal to 10 squared 3. So y prime is going to be 2tan 3 to the negative 1, and then times the derivative of 10. So it's going to be secant squared 3 phi. And then we're going to have the derivative of 3 phi, which is 3. Right, so again, 3 derivatives. The 2, which is, we can write it here, drops down here. We get a negative minus 1 over here, which is 1. Then we're taking the derivative of tangent, which we get secant, keeping this thing inside. Then we take the derivative of the thing inside, and we get k. Next problem is problem 33, where y, okay, I'm going to skip problem 33, because there's a secant involved, and I don't want to deal with that. Problem 34, y is equal to x sine 1 over x, so y prime is going to be x times cosine 1 over x times the derivative of 1 over x, which is negative 1 over x squared, right? So again, x, and then we take the derivative of that, which is cosine, we leave that, times the derivative of 1 over x, which is that, plus sine of 1 over x times the derivative of x, which is 1. So now problem 35, we have y is equal to 1 minus cosine 2x over 1 plus cosine 2x all to the 4th power. So y prime is going to give us 4. It's going to drop down 1 minus cosine 2x over 1 plus cosine 2x to the 3rd power. Now multiplying it by the derivative of the thing inside, we're going to get 1 plus cosine 2x times the derivative of 1 minus cosine 2x, which is times negative sine 2x times 2, minus, and now we're going to take 1 minus cosine 2x and multiply it by the derivative of 1 plus cosine 2x, which, wait a second, this should be a plus, right? Yeah, because there's a minus here, so we take the derivative of cosine, which is negative, but the minus cancels. Okay, and then this is going to be negative, now we have a negative sine 2x times 2, right? So this is being multiplied right there as part of the chain rule. Oh wait, and we divide all this by 1 plus cosine 2x squared. And then all this comes up here. And that's it. So that is problem 35. So the next problem is problem 36, which we have f of t is equal to the square root of t over t squared plus 4. So f prime of t is equal to a half of t over t squared plus 4 to the negative a half. And now we're taking the derivative of the thing inside. So we get t squared plus 4 times t times the derivative of t, which is 1, minus t times the derivative of t squared plus 4, which is 2t, all over t squared plus 4 squared. That's being multiplied with that. Okay. So now, problem 37, y is equal to 1 over tangent 10 of sine I, all this squared. So we have y prime is equal to negative of the derivative of that, which is going to give me 2 times tangent sine phi, and then times the derivative of the thing inside, which is secant squared of sine phi, and then times the derivative of sine phi, which is cosine phi. So that's what's going up on top, and then on the bottom we have 10 of sine phi squared. Okay, I'm going to, what should I skip? I mean, I want to finish the chain rule stuff by the end of this video. Maybe I'll just make it longer. Y is equal to ax plus the square root of x squared plus b squared to the negative 2. So y prime is equal, the negative 2 drops down and we keep everything else. And this is going to be a negative 3, and now we take the derivative of everything inside, which is going to give us a plus a half x squared plus b squared to the negative a half. And now we take this and multiply it with the whole thing is not multiplied, sorry. This is a half. And now over here we're going to multiply everything with the derivative of that, which is 2x. And that is it, right? Yeah, so the negative drops down. We keep this. We multiply by the derivative of this, which is a, times the derivative of this, which is right there. Perfect. Okay. Problem 39. Y is equal to x squared plus 1 minus 3x. 1 minus 3x to the 5th power. And all this now is to the 3rd power. So y prime is going to be 3x squared plus 1 minus 3x to the 5th power times to the 2nd power times the derivative of the thing inside, which is 2x plus now the derivative of this, which is 5, 1 minus 3x to the 4th power, but then the derivative of the thing inside, which is negative 3. That closes with that closes with that, and we're done. Okay, now, problem 40, sine of x, right, y is equal to that, so y prime is equal to cosine of sine of x times the derivative of the thing inside, which is cosine of sine of x, times the derivative of sine of x, which is cosine of x. Very nice. Problem 41. Okay, I'll skip the rest. and move on. I hope after all this everyone should be able to do the rest. I really don't like skipping, but whatever. So now we want to find the first and second derivatives of the function. The real point is for the people watching this to learn. So if they can't do 6 problems after all that, then what's really the point, right? So skipping is fine, I guess. So we want to find the first and second derivatives of h of x. So the first one is going to give us, actually, all of this on a different page. H of x is equal to the square root of x squared plus 1. So h prime of x is going to be a half x squared plus 1 to the negative a half, all times 2x, right? And then h double prime of x is going to be, and now we're going to use the product rule, so this is going to be x squared plus 1 to the negative a half times the derivative of this, which is 2, plus 2x times the derivative of this, which is going to give us a half times negative a half to the x squared plus 1 to the negative 3 over 2 times 2x. And that's that. That is first and second derivative for problem 47. Problem 48 gives us y is equal to sine 2 of pi t, right, which is equal to sine of pi t squared. So y prime is going to be 2 sine of pi t to the 1, and then we're taking the derivative of the thing inside, which is cosine of pi t, and then we're taking the derivative of the thing inside, which is pi, and y double prime is going to be, so the 2 and the pi don't matter, and we're going to create a product rule between those two, so we're going to have 2 pi times, then we're going to have sine of pi t times the derivative of this, which is negative sine of pi t times pi, and then this is going to be plus, right, this closes with that closes with that, good, and then this, good, plus, and then we're going to have cosine of pi t times the derivative of this, which is cosine of pi t times pi, and we're done. That's the second derivative. Okay, h of t is equal to tan of 3t, so h prime of t is going to be equal to secant squared of 3t times 3, so h double prime of t, right, this is the same as 3 over cosine of 3t squared. So h double prime is going to be, so it's going to be cosine times derivative, this times the derivative of that, which is 0, so we're going to have negative 3 times the derivative of the bottom thing, which is 2 times cosine 3t, all of that, times negative sine 3t times 3, all over cosine 3t to the 4th power, and we can say 3rd power and get rid of that. Okay, so that was problem 49. Problem 50, we have y is equal to 4x over the square root of x plus 1, so y prime is equal, okay, so we're going to have square root of x plus 1 times the derivative of 4x, which is 4, minus 4x times the derivative of the square root of x plus 1, all over x plus 1. So that's the first derivative. Oh, do we want to do the second derivative? This is a good question. let's see if we can simplify this. So this is going to be, no, it's not going to work. Interesting. Fine, I'll just run through the second derivative. I have x plus 1 times everything on top, which is square root of x plus 1 times 4 minus 4x a half. Wait, no, the derivative. Derivative times a half x plus 1 to the a half all times 4 minus, and then over here we're going to have 4 over 2, so this is 2, and then we're going to have a product rule, so we're going to have x times a half, negative a half, x plus 1 to the negative a half minus 1, and then plus a half, no, the half was x plus 1 to the negative a half times derivative of x, which is 1. All this minus, and then we just write all of this down, so let's call this a. So it's a times the derivative of x plus 1, which is just 1, all over x plus 1 squared. And I was serious shock if I didn't get something wrong there. But who knows? Okay, problem 51 asks us to find the equation of the tangent line to the curve at a given point. The curve is given in form of y equals 1 plus 2x to the 10th power. And we're trying to find the equation at 0, 1. So y prime, the slope is going to be 10, 1 plus 2x times 2. So at the point 0, so f prime of x at 0, f prime of 0 is going to be 10, it's going to be 20, right, and so then we're going to have y minus 1 is equal to 10x, and that's the equation. Okay, next problem, problem 52, we have y is equal to sine of x plus sine of x squared. So y prime is, and we're looking for the tangent line at the point 0, 0. So y prime is going to give us cosine x plus 2 sine x cosine x. So y prime, f prime of 0 is going to be 1 plus 2 times, okay, so this is 0. So that is equal to m. So we're going to have y is equal to x. Very cute. And now, problem 53, we have y is equal to sine times sine x, pi comma 0. So let's just write this in terms of f of x. So f prime of x is equal to cosine sine of x times f x times cosine of x. So f prime of pi is equal to cosine sine of pi times cosine of pi. So sine of pi is 0, cosine of 0 is 1, and so we have 1 times cosine of pi, which is negative 1, so we get negative 1, so this is equal to negative 1, which is equal to m. So we have y is equal to negative 1 times x minus pi. So our next problem is problem 54. We have y is equal to the square root of x plus x squared, the points 2, 3. So dy over dx is equal to a half of x plus a 5 plus x squared. to the negative a half times 2x. So dy over dx at the point x equals 2 is going to be equal to a half. 5 plus 4. 5 plus 4 is 9. Take this square root of it. It's 3, so this is going to be a third, right, because we have a negative here. And then we have a 4 here. So the 4 and the 2 are going to cancel. I'm going to get 2 over 3 is equal to m. So now we're going to have y minus 3 is equal to 2 over 3x minus 2. So the next problem that I'm going to do is problem 56. We have y is equal to the absolute value of x over the square root of 2 minus x squared, and we want to find this at the point 1, 1. So we just want to find the derivative next to this point. So the absolute value of x next to the point is just going to be equal to x. So we're going to have, let's just take y is equal to x over the square root of 2 minus x squared. So we have y prime is equal to the square root of 2 minus x squared times the derivative of x minus x times a half 2 minus x squared to the negative a half times 2x. Closes with that. So we close that over there. Yeah. All over 2 minus x squared. So now if we plug in a 1, we're going to get, so this is going to be, so we're going to get 1 over here minus, and then you have 1 here, and then a half. Then you're going to have 2 minus 1, which is 1, to the, so that's still 1, times 1, over 2 minus 1, which is 1. So this is going to give us, let's see, this is going to give us, sorry, this negative and this negative cancel, so that becomes plus. And then we put in a 1 over here, so we get a 2 over here, so we're going to get, so this is going to be 2. So now our equation is going to give us y minus 1 is equal to 2 x minus 1, y is equal to 2x minus 2 plus 1, where's minus 1? Okay. So the next problem, I'm going to skip problem 57, 58, 59, 60, okay, I'm going to do 61. We have f of x is equal to f of g of x, right? And we know that f of negative 2 is equal to 8. F prime of negative 2 is equal to 4. F prime of 5 is equal to 3. G of 5 is equal to negative 2. G prime of 5 is equal to 6. And we're asked to find f prime of 5. Well, f prime of x is going to be g prime, little f prime of g of x times g prime of x. So f prime of 5 is going to be f prime of g of 5 times g prime of 5, which is equal, so this becomes 6 times, and g of 5, so this becomes f prime of negative 2. F prime of negative 2 is 4, so we get 4 times 6. So that's the solution. Okay, so now problem 62, h of x is equal to the square root of 4 plus 3 f of x. So h, and now we're given f of 1 is equal to 7, f prime of 1 is equal to 4, and h prime of 1 is, oh wait, we're asked to find h prime of 1. So h prime of x is the same as a half 4 plus f of x times negative a half times, 3, yeah, times 3 f prime of x. So now h prime of, what was it, 1 is going to be a half 4 plus f of 1, which is 7, to the negative a half, okay, times 3, and then this is 4. Sorry, there's a 3 here. So this is a half 4 plus 21, so this is square root of 25, which is 5 times 12, which is equal, right, the 2 and this becomes 6, it's equal to 6 over 5. Okay, next problem. So I'm skipping problem 63. So I'm going to do problem 64, and in a more general case, right, they say let f and g be the functions in exercise 60. Oh no, I'm skipping problem 64 because we didn't do problem 63. Skipping problem 65 and problem 66. I'm going to do problem 57. Suppose f is differentiable in R, and we say f of big F of x is equal to little f of cosine x, and big G of x is equal to cosine f of x. So now we want to find f prime of x. So this is going to be f prime of cosine x times negative sine of x, right? And g prime of x is going to be negative sine of f prime of x, whatever that might be. Oh, sorry, of f of x times f prime of x. So the problem I'm going to do is problem 68. It says suppose f is differentiable in R, and alpha is a real number, and let f of x be equal to f of x alpha, and g of x is equal to f of x alpha. So we want to find f prime of x. Well, that's going to be f prime of x alpha times alpha x to the alpha minus 1 by the power rule and the chain rule, and g prime of x is going to be alpha times f of x to alpha minus 1 times f prime of x. Okay, next problem is problem 69. Q. We want r of x is equal to f of g of h of x, and we have h of 1 is equal to 2, g of 2 is equal to 3, h prime of 1 is equal to 4, g prime of 2 is equal to 5, and f prime of 3 is equal to 7 to 6, and we want to find r prime of 1. So r prime of x is going to be f prime of g of h of x, how close is that, right, times and then we're going to have g prime of h of x times h prime of x, right? Yes, that closes that, that closes that, that closes, good, perfect. So r prime of 1 is going to be, so let's start over here, h prime of 1 is 4, so we're going to have 4 times, and h of x, h of 1 is 2, so g prime of 2 is 5, so this is 5, and then h of 1 is 2, g of 2 is 3, so f prime of 3 is 6, so this is 6. Okay, next problem. If g is twice differentiable function, and we have f of x is equal to x g of x squared, so we want to find f double prime in terms of g, g prime, and g double prime. So f prime of x is, by the product rule, going to give us x, and then the derivative of this, which is g prime of x squared, times the derivative of the inside function, which is 2x, plus, and then you get this, which is g x squared times the derivative of x, which is 1. So that's f prime. So f double prime of x is going to give us, okay, so the x's can combine, so I can get 2x squared over here and get rid of that. So I'm going to have this, so it's going to be 2x squared times the derivative of g prime, so it's going to be g double prime of x squared times the derivative of x squared, which is x, plus, and now I'm going to take this times the derivative of that, so it's g prime of x squared. The derivative of that is 4x, so that is the derivative of this, and then we have plus the derivative of that, which is g prime of x squared, 2x. Very nice. So that's the second derivative of f. Okay, so now we are told that f of x is equal to f of 3 times f, okay, f of 3f of 4f of x, 1, 2, 3, and we have f of 0 is equal to 0, f prime of 0 is equal to 2, and so we want to find f prime of big F prime of 0, so f of x prime of x is going to be f prime of this whole thing, which is just 3, I'm going to erase this, 3 f of 4f, should have used g's instead of f of x, times the derivative of the inside thing, so that's going to be 3f prime times 4fx, and then times the derivative of this thing, which is 4f prime of x. So f prime of 0 is going to be, so again, let's start with this. So we have f prime of 0 is 0 times, okay. We have a 0 here, so the whole thing, no, it's a 2. Okay, so f prime of 2 is if 0 is 2, and now we have a 4 here, so we have, that's an 8, and then we are multiplying, so this is going to be 0, so the whole thing is going to be 0, so we have f prime of 0, so this is 2 times 3, 2 times 3, so this is 6, so that's that, and then we have f of 0 over here, so this whole thing is 0, so this whole thing is 0, so this whole thing is 0, so then over here we're going to have just 2. Okay, so for our next problem, I'm not going to do our next problem, or the problem after that. So let's do problem 75. The displacement of a particle in a vibrating string is given by the equation St is equal to 10 plus 1 over 4 sine 10 pi t. So we want to find the velocity of the particle and the, acceleration. Find the velocity. Okay, so S prime of t is going to give us a fourth cosine of 10 pi t times the derivative of this, which is just 10 pi. So that's that. Okay, I am going to do the next one. So we have, if the equation of motion of a particle is given by S is equal to A cosine omega t plus delta, the particle is said to undergo a simple harmonic motion. So find the velocity of the particle at time t. So S prime is going to be A times negative sine of omega t plus delta, and then this comes out, and we're going to get times times just omega, because the delta vanishes, and then it asks us to find the velocity when is the velocity equal to 0. So let's set this to 0. This vanishes, that vanishes, that vanishes, so we have sine omega plus delta is equal to 0, or in other words, one time, there are a bunch of times where this is equal to 0, but one time, for example, is when omega plus delta is equal to 0. So yeah, stuff like that. Or if you are in a period 2 pi, whatever. So I'm going to skip to problem 80, which says air is being pumped into a spherical weather balloon at any time t. The volume of the balloon is V. Time. Because that r is expressed in terms of t2, we can take d over dt of r to the third power, or in other words, but what is this? So this is dv over dt. It's going to equal to 4 pi over 3, and we're going to have 3r squared dr over dt. And the reason we can do this is because this, right, we basically can put it in, ignore the constant, and just have, right, if you have dy over dx, for example, that's just dy over dx. But if you have d of, let's say, y to the third. Not sure where this stops, but anyways, this is how we get this, and we're going to see this a lot when we get to related rates. And so now I'm going to stop over here and continue next time. Let me see, use the chain rule to prove the following. So I don't need to do problem 83 or 84 or 85, I don't think, or 86 or 87. I'm not going to do any other problems for the chain rule. I think I'm going to go immediately to implicit differentiation. So yeah, this is going to be the last. This is going to be the end for the chain rule. Everything else, just take the chain rule, follow the definitions. Not a big deal. Okay, and proofs generally you don't really need to know if you're taking Calc 1, and a lot of these are just proofs, which can easily be done using the chain rule. So the next video is going to be on implicit differentiation.